On the image, you can see the main components of the X-ray tube. The whole system is in vacuum, which is achieved with the help of the surrounding glass pulp. X-rays are generated with the help of accelerated electrons. These electrons are emitted from the tungsten cathode, which is heated up to very high temperatures. Due to the high voltage applied between the anode and the cathode, the electrons are accelerated towards the anode. And since the anode is heating up very quickly, it is needed to cool it down. And this is done with water cooling. As the electrons interact with the anode, X-rays are emitted. The generated X-rays leave the tube through a beryllium window. This material is used because it has a low atomic number, and therefore it doesn't absorb much of the X-rays. The emitted radiation consists of two components, Bremsstrahlung and characteristic X-rays. Bremsstrahlung is a form of X-ray radiation which is generated when the accelerated electrons slow down when interacting with the atoms of the anode. The energy of this radiation is very broad, and the intensity and energy of the radiation depends on the accelerating voltage, the filament heating current, and the anode material. Characteristic X-rays, however, have a very specific energy, which depends strongly on the anode material. The characteristic X-rays are generated when the accelerated electrons excite the anode atoms by kicking out inner shell electrons. In the relaxation process, a higher shell electron moves to the vacant spot and X-rays are emitted. The energy of the X-rays depends on the binding energy of the electron which was kicked out and the binding energy of the electron that came to occupy the vacant spot. Now this is a real X-ray tube with uranium anode. Two of the connections behind are used to heat up the tungsten filament, and the third one is for applying a high voltage between the anode and the cathode. Sadly, we cannot see much what is inside, but apparently in the case of this system, the X-rays are leaving the tube from the... In the case of twin anode systems, the anodes are made from different materials, and only one of the anodes is bombarded with the electrons at the same time. This allows fast and easy switching between the two exciting energies, and if one of the anodes should fail, then the other will serve as a backup. Using a rotating anode allows the heat to distribute on a larger surface area, and this allows to generate X-rays with much higher energies and intensities.